So in Lewis theory, we're looking at the valence electrons. We just learned about those. Valence electrons are the electrons in the highest principal shell of the atom. So whatever, 1, 2, 3, 4, that highest number that has electrons, those are the valence electrons. And remember, we predict the number of valence electrons for main group elements by just looking at the group number. Elements in group 6 have 6 valence electrons. So we take that main group element, and to write what's known as a Lewis symbol, we write the element symbol, say C for carbon, and then we represent the valence electrons as dots. And so we call these Lewis structures or dot structures or Lewis dot structures. They don't have really one universal name. Helium is an exception to that nice, convenient rule that the number of valence electrons equals the group number. What group is helium in? It's in group 8A, right, with the noble gases. How many electrons total does helium have? 2. Can it possibly have 8 valence electrons? No, it can't, because it only has 2 electrons. So helium has 2 valence electrons, 2 electrons. They're just both valence electrons. So let's look at just some atoms and write Lewis structures for these. Okay, so let's look at first the electron configuration for oxygen. So how many electrons does oxygen have? 8. It has 8 electrons. And as we've learned, we can look at the periodic table and get the electron configuration from there. It's going to be 1s2, 2s2, 2p4. Everybody okay with that? We can double check by adding up these superscripts. 2 plus 2 plus 4 is 8, so that's a good sign that we might be correct. These are the valence electrons. So there's 8 valence electrons. No. Wake up. I need to wake up and you need to wake up. 2 plus 4 is what? It's only 6. 6 valence electrons. It's in group 6. It's 6 valence electrons. Okay. Let me get my colors right here. So the Lewis structure for oxygen. You just write the element symbol, O, and then those 6 electrons are going to be represented as dots. Okay? By convention, we put the dots on the top, the bottom, the right, and the left. We don't make circles of them. They'll end up getting paired up if there's 8. So I'm going to go 1, oh wait, wrong thing. 1, 2, 3, 4, 5, 6. Okay, so there's a pair up here and a pair over here and 1 on the bottom and 1 on the left. Now you could draw them in many different ways. We could put the 2 pairs opposite each other like that. That's absolutely fine. We could put, the 2 pairs over there and the single pair, the single ones over here. It doesn't matter. Those are all equivalent. What you do not want to do, you don't want to do this. 1, 2, 3, 4, 5, 6. You don't want to just circle around. For one thing, it doesn't really look all that different than some of the other ones. Let me try that again. There, that looks a little different. We don't want to just put them in a circle. A very practical reason is it's hard to count them. Do you know why the spots on dice are always in the same arrangement? Because your eye recognizes, right? Oops, didn't want to do that either. Do a lot of things I don't want to do. On a die, that's singular for dice, 5 spots are always represented like that. Because you could just look at it and see the number. You don't have to take your finger out and count. I remember playing Monopoly with one of my kids when they were in kindergarten, and they hadn't realized that you can just look at it like that. Every time we rolled the dice, he had to get his finger out and count all the spots. It was so tedious, right? So we don't want to do this. By going top, bottom, left, and right, it's just convention. It's easier. Okay? Any questions? So each dot represents one valence electron. You put the dots around the element symbol, you have a maximum of 2 dots per side. By side, we mean top, bottom, right, and left. The exact location is not critical, but generally we put 1 dot on each position before we start pairing them up. And it's really important on mastering chemistry to do that because, mastering chemistry is very picky about particular things. If you have 8 valence electrons, then you're going to have 2 on the top, 2 on the right, 2 on the bottom, 2 on the left. It's very convenient that way. 8 dots is called an octet. Just like when in choir, an octet is 8 people singing, an octet is 8 valence electrons. Atoms that have 8 valence electrons are especially stable. What group on the periodic table has 8 valence electrons? The noble gases. Do the noble gases react with other elements? No. Until not too long ago, it was believed that they didn't form any compounds. Now we have discovered some compounds for a couple of them, but helium, we still don't know of any compounds that helium makes. And that's a challenge. There's people working on it because, you say this can't be done. The scientist says, well, I'm going to try, right? As long as I can get funding for that. So let's draw Lewis structures for the first 10 elements. Okay, so hydrogen, how many electrons does hydrogen have? 1. So it only has 1 valence electron, so we're just going to put 1 dot next to it. Doesn't matter exactly where you put it. How about helium? 2 electrons. So we'd like to put those unpaired. We're not going to do Lewis structures for helium much because the reason we're doing Lewis structures is to predict bonding, and helium doesn't bond with stuff, so we don't end up using it much. How many valence electrons does lithium have? I heard 3 and 1. 1 valence electron, 3 total electrons. We're only looking at the valence ones. The valence ones are the ones on the outside of the atom. Those are the ones that interact when elements bond with each other. So 1, sorry. How many valence electrons for beryllium? 2. I'm going to mix it up and go top and bottom. How about boron? How many valence electrons? 3. How about carbon? 4. It's in group 4. 1, 2, 3, 4. How many valence electrons for nitrogen? 5. So now we're going to have a pair, and then the other 3 are by themselves. We already saw oxygen. Oxygen has 6 valence electrons, so we're going to have 2 pairs and 2 that are not paired. How about fluorine? 7. How about neon? 8. 8 valence electrons. 2 on the top, 2 on the right, 2 on the bottom, 2 on the left. Doesn't that look nice and symmetrical? All these other elements would like to look like neon. They would like to interact with other atoms in such a way that they can get 8 valence electrons also. So we say that neon has an octet. So helium, what about helium? Does helium want an octet? No, he's too small. He couldn't handle 8 electrons. He knows that. He's got 2. That is the valence shell being full, because the valence electrons for helium are in the 1s orbital. There's only the 1 orbital with 2 electrons, and that's full. And so he's very satisfied. And hydrogen just wants to be like helium. He doesn't aspire to being like neon. So in Lewis theory, a chemical bond involves either the sharing of electrons or the transfer of electrons to obtain a stable electron configuration. So they're either going to share electrons with each other or transfer, one will give and one will take electrons, so that the atoms involved are going to have an octet. Except for the little guys, they're just going for a duet. There's two basic kinds of bonds. There are ionic bonds and covalent bonds. In an ionic bond, you have a transfer of electrons. The metal gives its electrons, its valence electrons, to the nonmetal. The result is you have two ions, a positive ion and a negative ion, and then they're attracted to each other because of their opposite charges. That's what an ionic bond is. In a covalent bond, co means sharing, right? Co-sleeping means you sleep in the same bed, which is what Andrew wanted to do last night. Covalent means sharing valence electrons, and that bonds the atoms together. And then what we have, what we call the octet rule, is that in chemical bonding, the atoms are going to transfer or share electrons to obtain outer shells with 8 electrons. In other words, to get 8 valence electrons. These little guys, hydrogen, lithium, and beryllium, follow the duet rule. Helium doesn't bond, so that's why he wasn't in that list. Questions? Okay, so let's look at magnesium and sulfur. Write the Lewis structures, it says. Well, to write the Lewis structure, we're going to write the element symbol. So for magnesium, the symbol is Mg. And then we're going to look at the periodic table and figure out how many valence electrons there are. Magnesium is in group 2A, so it has 2 valence electrons. So then we're just going to put 2 dots, 2 valence electrons. How about sulfur? How many valence electrons does sulfur have? 6. 1, 2, 3, 4, 5, 6. Any questions? One of the things I like about Lewis theory is it's so visual. Right? I can deal with spots, with dots, counting them up and getting the right number.